It's Mrs. Mafucci. Let's consider acid strength. In other words, what is it that makes something a strong acid? Since acids are mainly soluble in water, there has to be something other than solubility that determines how strong an acid is. Well, the first thing you need to know is that strong acids readily produce hydrogen ion. In other words, strong acids completely ionize in water, releasing the hydrogen ions that are present in the acid. Take a look at this diagram. A strong acid will completely ionize to produce ions. Notice that the HCl completely breaks apart to form hydrogen ions and chloride ions. That's because HCl, two nonmetals, held together by polar covalent bonding. Consider the ionization reaction for the strong acid HCl. You just looked at a picture of it. Here's the reaction. Remember, ionization is a two-step process that ultimately results in the acid reacting with water to produce the hydronium ion and the chloride ion. The equilibrium constant for this reaction is given by products over reactants, so the concentration of hydronium ion times the concentration of chloride ion over the concentration of hydrogen chloride. Remember, you never include pure liquids in an equilibrium constant. This reaction lies completely to the right, or goes to completion. That's why I wrote a single arrow for this ionization reaction. The KEQ, or Ka, of this reaction is very large. Remember, the larger the equilibrium constant, the more the reaction lies to the right and the more products are formed. Ka is the symbol for the equilibrium constant for the ionization of an acid. You have a table of ionization equilibrium constants for acids in your reference tables. Table M. If you look at Table M, you will see that the equilibrium constants are arranged from largest at the top to smallest at the bottom. The larger the Ka, the stronger the acid, and the more the reaction goes to completion. Strong acids have Kas greater than 1, favoring the formation of products and specifically the hydrogen ion. Remember, the more readily an acid produces hydrogen ion, the stronger the acid it is. Weak acids do not completely ionize in water, and instead an equilibrium is established between ions and unionized acid molecules. Look at this diagram. When water is added to HAC, that's the abbreviation for acetic acid. Acetic acid is a weak acid. Because it's a weak acid, that means that the hydrogen ions do not readily separate from the acetate ions. So at equilibrium, you have a mixture of both hydrogen acetate molecules and hydrogen ions and acetate ions. Weak acids do not completely ionize in water. Let's consider the ionization reaction for the weak acid, HAC. Remember, you never include pure liquids in an equilibrium expression. This reaction does not go to completion and establishes equilibrium that lies to the left, favoring the formation of reactants. In other words, this system will have more reactants, that's HAC molecules, than it will have ionized ions. Weak acids have Kas less than 1 and establish equilibrium, favoring the formation of reactants, the unionized molecules. The smaller the Ka, the weaker the acid, because the hydronium ions are not readily formed. Remember, the hydronium ion is a product. And since you have a small Ka and the equilibrium lies to the left, not many products are formed. Let's look at this diagram now that's going to show what happens when a strong acid ionizes and when a weak acid ionizes. Look at the second container. Do you see that the molecules have completely broken apart into separate ions? This shows 100% ionization. This represents a strong acid. Well, what would a weak acid look like instead? In the third container, you see that some of them have remained as molecules. Some are ions. This does not have 100% ionization. This only has partial ionization. That's why this is a weak acid.